for another lecture on the course Microprocessors and Microcontrollers. In today's class, I am going to explain about the 80386 and 486 microprocessor, their features. Right. So first of all, the introduction part of 80386. This 80386 microprocessor was designed by Intel in October 1985. And next, it is also known as i386, or simply we can call as 80386, or simply we can call as 386. In the designing of this 80386 microprocessor, nearly we are going to use 2,75,000 transistors. And one more interesting thing about this 80386 is it is used for designing of personal computers by Compaq. And this processor was available in 3 different versions, that is 80386DX, 80386SX, and then 80386SL. So this is some brief introduction part about 80386. Once again, I can recapitulate once again. So the first thing is, it was designed by Intel in October 1985, that is number 1. And number 2, it is also known as i386, or simply called as 386. And number 3 is, it consists of nearly 2,75,000 transistors. And the fourth one is, the first personal computer to make use of the 80386 was designed and manufactured by Compaq. And the last one is, it was available in 3 different versions, that is 80386DX, 386SX, and then 386SL. Now, I am going to discuss about the silent features of 80386. The first thing is like this, it is a 32-bit microprocessor. What is a 32-bit processor is? You remember, friends, this 32-bit, what it indicates is the word length of 80386. This 32-bit, what it indicates is, it indicates the word length of 80386. Now guys, what's the meaning of this word length? Word length means the number of bits recognizes or processes by a processor maximum at a time is called word length. That means this 80386 processor can recognize the 32 bits at a time, or it can process 32 bits at a time. That means indirectly you recognizes in the sense this processor is able to transfer at a time 32 bits, or it can receive 32 bits at a time. That indicates recognizes. And the second thing is, it can process 32 bits. That means this 80386 can do their operations maximum on 32 bit. So that is the meaning of this first statement. It is a 32-bit microprocessor. That means the word length of 80386 was 32-bit. And coming to the second one, its ALU capacity is 32 bits. Just now I told you that the word length of what it indicates is the number of bits it recognizes are processes. The word the processes is related to ALU. Here the 80386 ALU capacity is 32-bit. That means this 80386 processor can do their arithmetic as well as the logical operations maximum on 32 bits. That is the meaning of a second statement. And coming to the third one is, it supports 8 bits, 16 bits, or 32-bit data operands. The meaning of this one is, this 80386 can do their arithmetic or logical operations either on 8 bits, that means it can do their operations on bits, or it can do their operations on 16 bits, or it can do the operations on 32 bit. That means your 80386 can able to go and do their operations on these 3 different data operands. One is 8 bits, second one is 16 bits, and third one is 32 bits. And coming to the next, it has 32 data lines. So already we discussed about this, because this 80386 processor word length is 32-bit. The word length means the number of bits it recognizes. The meaning of that one is the number of bits it transfers, or the number of bits it receives maximum at a time. Your processor can transfer 32 bits at a time, or it can receive a 32 bit at a time. That is happened with the help of data lines, so that your 80386 has 32 data lines. So that is the thing. Next, coming to the next feature is it has a 32 address lines, that is A31 to A0. That means this processor has total 32 address lines. By using a 32 address lines, this processor can able to generate total 2 power 32 different combinations. Each and every combination you can assuming as one address. So the number of addresses your 80386 can able to generate is 2 power 32 addresses. That means it is equal to 4G. That means your 80386 can able to address up to a memory of a size of 4GB. That means 4 gigabytes of memory my processor 80386 is able to address. That is the meaning of this. Next, it will support a virtual memory of a size 64 TB. It is a wonderful feature that 80386 has. Because before the 80386, no processor didn't know a concept, virtual memory concept. But coming to your 80386, it supports a virtual memory of size 64 TB. Can you imagine, guys? This processor was designed in the year 1985. That time itself only, the processor knows the utilization of virtual memory concept. This virtual memory concept nowadays we are using our systems. The utilization of your hard disk in your system, that is a one form of virtual memories we use in our systems. So your 80386 processor supports a virtual memory of size 64 terabytes. So that's another interesting thing about this. And next, coming to it supports a memory segmentation. What this is? So once you know about 8086 processor, your 8086 processor supports segmented version of memory. We know that by utilization of segmentation concept, we may get a different advantages like efficient utilization of memory space, and it can also support a parallel accessing, that means parallel processing, and it can increase the security levels, and all these advantages we are getting. In the same thing, your 80386 continues 8086 segmentation concept, that is, it supports a segmentation concept. And the next thing is it also supports a paging concept. You remember, friends, segmentation and paging both we consider as memory management concepts. If I want to go and use effectively the processor supporting memory in my system, definitely I have to go and use the segmentation concept as well as a paging concept. So here important thing, now listen friends, before the segmentation we have virtual memory. Once we have a virtual memory, we are going to generate an address called a virtual address. The virtual address is converted to that is called a linear address, that will happen in segmentation, and later that linear address is converted to physical address, that was done by a paging. That means your virtual address first converted to linear address and later it is converted to physical address. If you are observing this sequence, what happens is two-step address conversion, that is from virtual address to logical address, that is a virtual memory address is converted to linear address by using segmentation concept. Later the linear address is converted to physical address by using a paging concept. Now later I am going to discuss much more about what this segmentation, what this paging and virtual memory. Don't worry about this. As of now, you remember your virtual memory may get virtual addresses, and that virtual address first converted to linear address as a first step that we do with the help of a segmentation. Later that linear address is converted to physical address by using a paging. So here there are two-step address conversion process we identified in 80386 processor, that is from virtual address to a physical address, guys. Next, it has a 4 levels of protection mechanism. Yes, it is another interesting feature that we found in 80386. So what this protection mechanism is? So it is, remember guys, if you go and take your system may consist of system software as well as user memory. That means a system software, that means the programs which are needed for proper working of your system, which may consist of operating system kernel, operating system extensions as well as the device drivers. Everything exists as in your system as a system files. Along with that, we have some of the portion of memory is dedicated for user programs. So once you have this protection mechanism, the user is unable to access the information what is there in OS, or it is there in OS kernels, or what is there in IoT device drivers. It is the only user can access the space what that was dedicated to user itself. Due to this, what happens is the security for the information of your system is more. So that is possible in case of 80386. So here 80386 will support 4 levels of protection mechanism. And next, it has a mathematical coprocessor which is 80387. If you refer 8086 also, it has a mathematical coprocessor which is 8087. But coming to 80386 has a mathematical coprocessor which is 80387. What is a mathematical coprocessor concept is? So once your processor going to execute some program, it may identify some of the instructions are related to some mathematical operations. Those instructions can't executed by your 80386. Then what your 80386 can do is, it simply bypass those instructions to this coprocessor 80387. This 80387 taking care of those mathematical related instructions. They can execute it and they send back our results back to 80386. It means by utilization of this 80387 in your system, we can reduce the burden on 80386 when it will go and do different mathematical operations. So 80386 have a coprocessor which is 80387, which is taking care of mathematical operations. And next, its instruction set is upward compatible with all its predecessors. What is the meaning of this, guys? So the meaning of this upward compatible means your 80386 is a 32-bit processor. Before to this, we have a 16-bit process like 8086, 8088, 80186 and 80286. If I want to use 80286 or 386 in place of 8086 or 8088 or 186 or 286, no doubt my system performance is increases because its word length is double compared to those of previous processors. Once your 80386 is upward compatible, it means what are the programs we developed for 8086 or 8088 or 80186 or 80286, without modifying at least a single instruction of that application program, we can execute on this 80386 processor. That is the meaning of this upward compatible. I repeat once again, guys, the meaning of this upward compatible feature of 80386 is what are the application programs we developed for 8086 or 8088, 186 and 286. Those are programs we can execute by using 80386 without modifying at least a single instruction in the application program. So that is the meaning of this upward compatible. And next, it supports 11 different addressing modes. But out of these 11, we are mainly focusing on 3 different addressing modes. Those we are calling as indexed addressing modes. So out of 11, 3 addressing modes are related to indexed addressing mode, and remaining 8 addressing modes already what we learn in 8086. The same addressing modes we are using in 80386 also. The additional addressing modes what we are learning in 80386 was indexed addressing mode. So at the time of an addressing modes, I will go and discuss much more about what is 11 different addressing modes which are supported by 80386 microprocessor. And next important thing is, it can be operated in 3 different modes. Basically, we have only 2 different modes we identified. One is a real mode and second one is a protected mode. But in that protected mode itself, we have virtual 8086 mode, or simply called as virtual 86 mode. If you can't take this as a separate mode, then your 80386 will support 3 different operating modes. One is a real mode, and second one is a protected mode, and third one is a virtual 86 mode. These are the 3 different modes. In upcoming classes, I will go and discuss much more about what is a real mode operation, what is protected mode operation, and what is virtual 86 mode operation. So don't worry about it. Next, its operating frequencies, that is from 16 MHz, 20 MHz, 25 MHz, and 33 MHz. Just you remember, guys, if you go for 8086, its operating frequency, the maximum is 10 MHz. Minimum frequencies are 5, later 10 and 8. We have a different versions of 8086. Like 8086, 8086 underscore 1, 8086 underscore 2. These are three different versions, have a three different frequencies like 5 megahertz, 10 megahertz and 6 megahertz. In a similar way, coming to 80386, it was exists in a different versions. Each and every version has its own frequency. The minimum frequency for 80386 operation was 16 megahertz and maximum is 33 megahertz. So try to think, guys. Your 8086 operation is a 5 megahertz, but coming to 80386, the maximum operating frequency is 33 megahertz. That means 6 times the speed of operation of your 80386 is more compared to 8086. If you consider 8086 operating frequencies at 10 megahertz, nearly more than 3 times your 80386 operation is more compared to 8086, because the maximum operating clock frequency of 80386 was 33 megahertz. So minimum is 16 megahertz and the maximum is 33 megahertz. Next, the different versions. I'm already told you guys 80386 was available in 3 different versions, like 80386DX, or simply we can call as 386DX. And second one is 80386SX, or simply we can call as 386SX. And last one is 80386SL, or simply we can call as 386SL. Now we'll go and discuss what these are 3 versions. The first version is 80386DX. This is we can call as full version of 80386, guys. So what I'm going to be discussing in upcoming classes. So those are purely I'm going to discussing about only 80386DX. I'm not talking about 80386SX as well as I'm not talking about 80386SL. I was only focusing on 80386DX. The first thing, what this DX means. You remember, friends, that DX means a double execution. Double execution. So this is the meaning of DX. So 80386 DX means DX represents double execution. The first member in 80386 family. This 80386DX was the first family member in this 80386 family. Next, this CPU could work with 16-bit as well as 32-bit external buses. That means this 80386 have 32 data lines maximum, and sometimes we have to go and use a 16 data lines also. That is, it depends on your processor can communicating with the IO device as well as a memory element. So here the maximum data lines, the 80386DX can use this 32, and the minimum it is equivalent to 16 bits. That's the meaning of this. Next, it is comprises of both the 32-bit internal registers and 32-bit external bus. That means if you go and refer your 80386DX, it has a certain number of registers. In this register, some of them are comes under user accessible and some of them are comes under machine accessible. But these register sizes are 32 bits. And one more thing is it has to go and use a 32-bit data bus. Just now I discussed. And coming to the last important thing is this 80386 processor was available in a 32-pin pin grid array package. That means your 80386DX, the package which is available in the form is 132-pin PGA package. That is a pin grid array package. So that is about 80386DX. Once again I repeat, it is the first member in a family of 80386. And second thing, it has to go and use all 32 data lines to communicating with our external devices, or it will go and use the 16 data lines also. And if I go for the internal structure of this 80386, it can do their arithmetic and logical operations maximum on 32-bit because its ALU capacity was a 32-bit, and second thing is its internal register sizes are 32-bit. And final point is 80386DX was available in 132-pin PGA package. PGA means a pin grid array package. So that you have to remember, friends. And coming to the second version is 80386SX. It is a reduced bus version. That means instead of using 32 data lines or instead of using 32 address lines, here I have to go and reduce that bus width. So that's what is called the reduced bus version of 80386. So here this SX represents a single execution. So it represents single execution. Previously DX represents a double execution. So here this is what I can call is the reduced bus version. That means the address bus width is reducing from 32 lines to just 24 lines. And another thing is it's a data bus width also reducing from 32 to 16. That's why it is called reduced bus version. And coming to this, a low cost version of 80386. Once you are reducing a bus width, automatically the complexity of your processor can be reduced. Automatically it will influence the cost. So it is a low cost version of 80386. This processor has a 16 external data bus and 32-bit internal registers as usual, but a 24-bit external address bus. Just know what I am saying. It has a 24 address lines and it has a 16 data lines. But I have not touched the internal registers. Their sizes is still a 32-bit. That means it is coming to the internal part. It just looks like your 80386DX. But coming to the external part, what happens is when your 80386 can communicating with the external world, that means it is communicating with either memory or with an IO device. It just go and use 24 address lines or 16 data lines only. So that's important. And the last part is once the number of address and data lines are reduced, it automatically influences the number of pins that are exist in IC form of our 80386SX. So that is clearly here we are observing, guys. This 80386SX was available in just 100 pin flat package. So previous case 80386DX was available in 132 pin PGA because there we have a 32 address lines and 32 data lines, but coming to 80386SX it was just available only in 100 pin flat package because here the address lines are reducing from a 32 to 24 and data lines are reducing from 32 to 16. So that is the second version. Coming to the last version, that is 386SL. It is a power efficient version of laptops. It is a power efficient version for especially laptops. So it is a less power, it consumes a less power. So low power microprocessor with power management features with 16-bit external data bus and 24-bit external address bus. It just looks like our 80386SX. But only the difference here is it consumes less power because it has a power management feature exists. It is suitable for laptops. So that's important. The processor includes ISA bus controller, memory controller and a cache controller. These are the general features that exist in case of 80386SL. I hope guys you understand these are three different versions of 80386. One is the 80386DX. 80386SX and the last one is 80386SL. So I hope guys you enjoyed the class and so we'll meet in next class. Thank you for patient listening.